Welcome to Program Guru. In this mock technical interview, a candidate is asked to solve a classic array problem involving selecting two items whose sum matches a gift card amount. Watch how the developer clarifies ambiguities, performs a dry run, and walks through both brute force and optimized approaches, just like in a real FANG interview setting. Let's start the interview.
The requirement is, consider that you're on a high-pressure shopping game show. You're given a list of item prices and a gift card loaded with a certain amount. Your goal is to pick exactly two different items whose prices add up to the gift card value. Return the indices of those two items.
Sounds exciting, just a few clarifications before I proceed. First, are the prices sorted in any particular order?
No, the prices can be in any random order.
Got it, and can we use the same item twice if its price is exactly half the gift card amount?
Nope, you can't pick the same item twice. The two items must be different.
Alright, final check. Will there always be exactly one valid pair?
Yes, a valid solution exists in each test case. Even if there are many, you may return the first valid pair you found.
Thanks. To confirm my understanding, if prices equals array of 10, 20, 30, 40, 80, 100 and gift card equals 60, then indices 1, 3 is valid because 20 plus 40 equals 60. If prices equals array of 25, 25, 50 and gift card equals 50, then valid indices would be 0, 1 and not 0, 0. If prices equals 1, 2, 3, 4, 5 and gift card equals 9, then answer is 3, 4 since 4 plus 5 equals 9. Does that align with the problem intent?
Yes, those are spot on.
Awesome. Now let's dry run with your example. Prices equals 10, 20, 30, 40, 80, 100 and gift card equals 60. Check 10 plus 20 equals 30 not equal to target 60. 10 plus 30 equals 40 not equal to target 60. 10 plus 40 equals 50 not equal to target 60. 10 plus 80 equals 90 not equal to target 60. 10 plus 100 equals 110 not equal to target 60. Check 20 plus 30 equals 50 not equal to target 60. 20 plus 40 equals 60 equal to target, which means we can return the indices 1, 3. This matches your expectation, right? I'll start with the brute force approach to build my understanding of the problem. Since I need to find two different items whose prices sum up to the gift card amount, the most straightforward way is to check all possible pairs. I can use two nested loops. The outer loop will pick the first item, and the inner loop will check every other item after it to see if the sum of the two equals the target amount. If a match is found, I'll return their indices immediately. Since the problem says there's at least one solution, I don't need to worry about handling multiple results or no solution. This solution checks every possible pair exactly once. The time complexity is O of n square, where n is the number of items. Works fine for small inputs, but not scalable.
Right. Can you improve it?
Yes. I'll use a hash map to store prices I've already seen while iterating. For each price, I'll check if the complement, which is target minus current price, is in the map. If it is, that means I've found two prices that add up to the gift card amount, so I can return their indices immediately. This is O of n time and O of n space. We're scanning the array once and map lookups are constant time.
Sounds great. What about tricky inputs like duplicate numbers?
Good point. Let's say prices are 25, 25, 40 and gift card equals 50. On first 25 index 0, I store it in the map. Second 25 index 1, complement is 25, then map has it, then we return the indices 0, 1. Since we store prices after checking for complements, we naturally avoid using the same index twice.
Exactly. I like how you're anticipating edge cases and validating with examples.
Thank you. I'd also write unit tests to cover random order inputs, duplicates, negative values if allowed, though not mentioned in this case. But since input is always clean and guarantees a unique answer, that simplifies the test matrix.
Great walkthrough. You approach the problem methodically, starting with clarifications and dry running through the example, which showed good attention to detail. Your transition from brute force to an optimized hash map solution was well articulated and efficient. One strength was your ability to anticipate edge cases, like duplicate values and index handling. Your explanation of time and space complexity was also clear and concise. In a real interview setting, I'd encourage you to verbalize trade-offs a bit more, especially around why one solution might be preferred based on input size or constraints. But overall, very strong performance.
Thank you for watching. Please like the video and subscribe to our channel.